All right. So distribution, forward and backwards. So if we're going to go forward, we need to take this value here and distribute it to each of the terms inside the parentheses. So the easiest way to think about this is think about the numbers being multiplied to the numbers, the x's being multiplied to the x's, and the y's being multiplied to the y's, one term at a time. So if I take a look at 3x squared and 2xy, I first just say 3 times 2 is 6. X squared and x to the first, that just means that's x cubed. Remember, you add the exponents. And y times y is y squared. All right, so now we're coming over here to 9. So once again, we're going to go, we're done with this guy. Oops. Up, up, back. So now we got 3 times 9 is 27. X squared times x is x cubed. And y times y squared is y cubed. And it's going to be addition. And finally, the 3x times the 1 at the end, 12x. So 3 times 12 is 36. And x squared times x squared is x to the fourth. And y times y cubed is y to the fourth. All right, so we just distributed that 3x squared y into the parentheses. All right, so I want you guys to try it out. Good luck. How do you pause this thing? What's going on? Where's the pause button? Oh my God. Oh, there it is. So we've got distribute. 2 times 5 is 10. X times x is x squared. And don't forget the y squared at the end here. Now 2 and the 3. The 2 times negative 3 is negative 6. X times x squared is x cubed. And the y just comes along for the ride. And finally over here, 2 times 4 is 8. And there's that extra x. And that should have been your answer. Great. All right, now what happens if I want to go backwards? Uh-oh, I'm going to go backwards. What this is called is undistribution. No, kidding. It's called factoring. Factoring, although I prefer undistribution. So what you're really trying to do is get all the things that are alike. So inside the 6, I see a 2 times 3. Inside the 8, I see a 2 times 2 times 2. Inside the 12, I see 2 times 2 times 3. And there you go. Now they all have a 2, don't they? In fact, if I want to get crazy with this, I could express this all together. I can actually stretch this out and go 2 times 3 times 1, 2, oops, sorry, 2 x's and 1, 2, 3, 4 y's. That's me literally expanding that out. Similarly, 2 times 2 is 4, times 2 is 8, and then I've got 3 x's and 1 y. And finally, I've got 12, which is going to be 2 times 2, which is 4, times 3 is 12, with 1 x and 2 y's. And then I just got to go through this and say, hey, what do they all have in common? They definitely all have a 2 in common. They definitely do not all have a 3 in common. There's a 3 here, there's a 3 here, but there is no 3 here. So I cannot take out a 3. What about another 2? Nope, this one just only has 1, 2. So now we move on to x's. How many x's can I pull out of this? I see 1x here, 1x here, and 1x here. Oh, and look, there's only 1x to give up. So that's the most number of x's I can give away. And finally, y's. I've got y here, and a y here, and a y here. But notice this only has one y to give up. So that is it. The only thing I can pull out of this is a 2, an x, and a y. Everybody else stays inside. So what do I mean by everybody else? Everything left over. 3x and 3 y's. 3x and y to the third. Here's going to be 2 times 2. That's 4. X times x, x squared. Here I've got 2 times 3 is 6. And the only thing that's left behind here was a y. And the thing is, if I were to take this 2xy and distribute it forward into this problem, I would get all the way right back to the very beginning. And that's how you know you did it right. Okay? All right. Now you guys try. Give that one a shot. And where'd that pause button go again? Where, there it is. No, wait. That's not it. There it is. Okay, we're back. So we've got, we want to try and undistribute or factor. So again, I'm going to think of this 12 as 2 times 2 times 3. That's 4 times 3 is 12. Oops. Boy, that's just 2 times 3 times 1, 2, 3 x's and a y. The 15 is going to be 3 times 5, 2 x's and 2 y's. The 18 is going to be 2 times 3 times 3, right? Because that's 2 times 9, basically. 2 x's and 4 y's. 1, 2, 3, 4. All right. So what do they have in common? Not everybody has a 2. Right here, no 2's. So I can't take a 2 out. They do all have a 3, though. There's a 3 here, there's a 3 here, and there's a 3 here. So a 3 is definitely coming out of this one. 5, that's the only one with 5, so that's not going to happen. How many x's can I pull out? I see I can take 2 x's here, and 2 x's here, and 2 x's here. Nice. How many y's can I take? Well, this only has one y to give away, so I can only take one y from each of these other ones. And that's it. Those are all the same values, so I'm going to pull out the 3, the x squared, and the y, and I'm going to leave behind the 4x plus 5y minus 2 times 3 is 6, and I got 3 y's left over. And that's it. Once again, if you want to double check yourself, you could distribute that through and to see if you get the exact same answer. All right, hopefully that helped.